Thank you so much for having me. Hi, everyone. Uh, I'm gonna try to take the topic a bit far from the scientific world, and give you a bit more of a journey which we had for starting the DynamoBot, but it was basically in mixture with my the PhD, so it's gonna be a mixed story. I think so. So the project basically, as you might be familiar, my PhD was about building this robot, which is called BoneBot, and it does plant level intervention and precise interventions in the field. Um, but I just wanted to look at look at the problem from another perspective and say, and start with basically a general topic of uh, uh, this past that everything basically starts with a problem. Um, let's say that you're a graduate from master's students, master degree, or even your PhD, or even before that, and then you basically either you want to pursue your path with education and go to a PhD position or the next level, whatever it is, or you want to start a job or basically get hired with join a corporate or or like a company to get your life going and get to your goals. But always the matter is finding a valid and valuable problem that you will actually solve. If it's going to be joining a company, you need to be bringing value to that company, or it's going to be a problem that you're going to solve either in your own startup or in a PhD student as a PhD student. Yeah, then again, you need a valid problem to solve it. So a valid problem basically can be defined scientifically, like you define a topic which is not touched anymore or that much, it's not that often, and there are not many scientific publications about it, or it's pretty interesting and it's a hot topic nowadays, like AIs or application of AI in every corner aspects of the different subjects like agriculture. And then basically there are two ways. Either you find the professor or a professor finds you. So this problem basically sits in the desk of a professor with money and hopefully a open position to offer to someone, or it's another way that you will look for a professor. And this maybe the first case is basically what happens mostly in North America and in Europe is maybe the other way that there are positions and then basically you apply for them by the professors. And then if basically the scientific problem is found and it's valid, and then you um, get the magic work, and then you get the position from the after a few reviews, and you basically get the position of the professor. You get a job for N years, and yeah, you say, "Congrats to me! I'm gonna go for N years safe and do what I love to do." But actually, it turns out to be not that correct because you start basically with passion. And then, yeah, as the contract goes on, and then you pass the years, you see that, okay, I need to do and get to different deadlines, publish different publications in different journals, and then some opinions, subjective and objective, of different people, which you haven't seen as reviewers of your papers, will really affect on the quality of your life. So that is not that much, I would say, pleasant, but this is something which you will see it afterwards. And sometimes it could be pretty stressful. Sometimes it could be, yeah, kind of dealable. But then there's another way. Um, if you find a problem which people want to pay for that. So in the first case, you have find a problem which is scientifically valid, and basically your professor or university or government is paying for that. But the validation or being like a finding a valuable problem maybe could be defined another way. When you find a problem which people could actually um, pay for that. like not one people, like not one person, just a few people, or like in a best case, a society or a country, or even in a global manner, like the whole world. This is something which gets you a bit more to the path of a startup, or finding a path, or kind of lighting some um, basically lamps in your above your head, basically. For example, one of those problems could be a recursive problem. So that is a property which that problem should be having. It should be recurrent, because if you have found a problem which you solve it one time and then that customer goes off, completely off, then there's a factor of risk. It's a high factor of risk for that, and it's not going to be a idea for a startup or something which you can make money, or I don't know, just establish a company on top of that, because you want a problem to be solved, and uh, the problem should occur by itself, by its nature. So it should be a recurrent problem. I mean, sorry for some typos. And um, another factor which is pretty important in the topic of startups, or the problem which you're going to solve, basically, is the current solutions which are out there are not satisfying the customers, or they are not actually giving the customers the value, or they are actually having some other problems, like there are some additional problems, they are scarce, they are costly, or it's pretty risky actually to find, or it's basically the accessibility is really low, or yeah, for example, in agriculture, you can think of a farmer, they do not trust to a robot which it works by its own, because and they can't put it outside because they are used to a implement in back of their tractor which they could put it out. It just lift it up with the tractor and then put it out. If it doesn't work, if it works, then just bring it out, bring it in. But when it's a robotic system which it moves by itself, and it doesn't have any hitch or anything, any mounting point, then that is a really much more harder problem to sell, to give service with such a problem with that solution, I would say. And then you say, I found, yeah, I found at some point I found the problem which it's valid, it's recurrent, it brings a value, and I have thought a solution about it, or I actually was a volunteer to actually um, spend my time to solve that problem. And then you might think of, okay, I'm gonna be rich, I'm gonna be my own boss, and I'm gonna be famous. There's not gonna be any deadline. I'm gonna take vacation and do my job, and no one will give me any deadline or any critic or anything. But actually, here also there's a bigger disclaimer or in the butt, and says that the story is not gonna be like that. Being an entrepreneur and starting a startup is, everyone says it's pretty hard, and I'm not gonna disagree. It is really hard, because if you're in the scientific world, you're dealing with one person, like a professor, or even two, or even three, I have seen. And the university is actually giving you a proper, safe environment to do your research, and provides most of what you need. In the startup world, basically, you have an idea, you have a problem which you think it is pretty valuable, or it's worth actually spending time, or it will generate some money and be valuable for the society. And then um, the point is that that is in your mind, and there are so many processes to validate it, to make the business case about it, to find the money to implement for implementation. There are different rounds for the implementation, and then you need to actually find some crazy people to basically believe in you. Yeah, so it's like a team that the people are crazy enough to believe in you and your uh, fantasy, like the idea that it might work, and it might not. So this is maybe the case for all the startups. If they are walking in the edge of the technology or the solutions, and they are not basically replicating something new. Yeah, there are so many other stress sources, I would say, but these are the main ones which I can um, bring up. But there are so many of those which basically they are gradually showing up in your path. But um, and one of the ones which basically makes them harder is that you don't have that support and the money actually to run your daily life, because everyone at the end at night actually needs a dish of food and then a place to rest. So you're basically risking that. Um, and it's not only that, so it's not only having money to live, it's the money to pay to the team, to the crazy team, to yourself, to build a project, to push the project forward, to get the ideas, to validate the ideas, and to get the results which you think they will make you a proper candidate for actually selling something and getting the market outdoors, which you basically don't know what is the market, where it's located. Is it a location? Is it a like a group of people? You basically at the beginning you don't know how your market is looking like. And then all of these are basically gathering together, and then at the same time you need to pitch. So this is something which you need to do every day. Every day, different cities, different people, and new people are showing up asking random questions. Um, and you need to explain, rephrase, and update your pitches and your idea, and try to basically retrofit that idea in a business plan and all the aspects of the market and how the business will go, how the technical will follow up, and management of the team and all of that, uh, and then basically collect it in a pitch deck. And then wherever you go, you need to basically talk about that and try to convince people to support you, or you can basically get some investment. I mean, there are some other ways like bootstrapping. Like if you have, um, there's say there's a term saying 3 Fs, like fools, families, and friends. If you could get monies from those 3 F, good luck. Uh, but I guess it's not going to be much. So beside that 3F, you will actually need to attract some investors. So that's why, and you basically need the network effect to work for you, that you get your startup known to other people, that they could actually talk about you. Like just uh, imagine how the other companies, big companies, are working. So everyone knows when they talk about a phone, okay, there are some names that they will come up. You want to get to some of those levels, that when people are thinking about that specific problem which you have uh, found, they just think about your name, or just your name just pops up in their mind. And then, yeah, as I said, you pitch. You need to build, measure, learn, and update what you've done. Again, you need to pitch, and then again, and then. So it will continue until basically you get lucky enough, or you get professional enough. I mean, they're both at the same context. I would say they should be all together. And then you can find an investor, and the product market fit is good, and then you can push your startup forward. It's pretty hard, but actually, I'm gonna say there's a bigger what, that uh, if you love what you're doing, that's gonna be your thing. If you're passionate to actually bring value to the society, give something back, if you have done a PhD or a master's, and then you think that you have genuinely have an idea that you can um, create some value, then I think you're in the right path. It will take time. I'm in the path. I'm not at the end. I'm not even close to it, really far from it. But based on some experiences from the years which I was working in several startups and the ones which I had, yeah, this is what I could say. And then, yeah, that's until here. I just try to give you an overview about the whole startup and the PhD path. Uh, and now let's focus on what I picked to work on. So I started my master's degree in Uni 1 in 2017, and then in Cyril's lab, started working actually building a robot, agricultural robot for that. At that time, I did not have any experience in field robotics or agricultural robotics, but it was more on humanoid robots and UAVs and stuff, like around more than 10 years at that time. And then started building this agricultural robot, and because I was always passionate about agriculture, like the being in nature was giving me good feeling. Then I thought, okay, there's a really great and untouched world, um, and this seems to be a really creating a valuable asset, and it's creating actually it's creating value for the society. Why? Because I saw that there are this group of people like farmers that they produce all the foods for the society, for the people for the other people, and then they have basically so many problems. Just one example is this hand weeding problem. Like when you're buying something from a biomarkt, is basically you should think of this is a bio product which no chemicals has been used on that for something like this, but how they have produced it. So basically, for a sugar beet, this is from LOIs, like the letters of intent of which farmers gave us, which they were interested in our solution. It basically takes more than 100 hours. I mean, the real number in some statistics is 300 hours for hand weeding the sugar beet for 1 hectare. So either they need to find people to multiply and divide that um, hours, or basically the other way. So either you need to just go and do it by yourself, and then it takes forever, or the other way that you need to find the people, and they are pretty expensive, and it's pretty hard to find them. It's pretty risky for them, for the farmers to actually rely on such forces and manpower. Uh, and yeah, we just I just checked the whole technologies or the solutions which we had around and say, okay, there's these chemical solutions which basically they go to the farm, they spray everywhere, unless without any um, considering a consideration of is there any intervention needed in all the places? Is there any weed or any unwanted plant in the farm or not? And then when they want to do it a bit better, it gets mechanically, which you can see that how the soil is getting disturbed with just one pass, which just makes the soil erosion faster. It makes the humidity loss of the water faster, and then basically by rotating the soil, you can basically seed new types of weed, because the seeds of weeds are on top of basically are on the top of the soil. And then when we basically want to do it, the best is basically like this, as I said. So they need to basically hire people to do the hand weeding, and it's pretty laborious, pretty costly, and it's pretty hard to actually manage all of them, because you can't rely, and you might teach someone to do a specific job this season, and then next season he's not going to be there. So as a human, we are not that predictable. And then, yeah, we just thought how we are gonna do this, how we are gonna um, solve this problem that is something which offers a selective and human level precision. Besides it should bring some flexibility and some other features to the game. Um, as I mentioned, in only chemical, so basically there are different, if you consider different type of plants, all the plants get treated with the same methodology. But what we are offering here is basically this um, um, kind of a reformulated and a multi-head technology, which could enable farmers to conduct plant level intervention or the plant specific interventions in the farm. And it's basically better than um, um, human and the hand weeding, because it could then do several applications or several tasks at the same time, and you will see it in the later slides. So the project started in 2019 when I started my PhD, and then basically COVID hit, and then we um, stored the robot somewhere close to a farm to don't miss the time. And yeah, started building everything in that garage. And then system basically got built throughout the years. Every year we just updated the sensor system, the locomotion and navigation system, and then we decided we just worked on the vision system, which was used basically to perceive the farm and to perceive the plants. Uh, and then with some hypotheses, we started building the reading tool, which we had in mind. We just wanted to deliberately to have something which is flexible enough, and it could operate or use different types of nozzles altogether. So we basically introduced a concept of a multi-head nozzle, which all the nozzles could move. And here I'm gonna show you some videos a bit later. And it was basically, you see that from 2019 to 2020, yeah, 2025 or 2024, it's a long time. And then every year you're updating that robot, taking it to the farm, measuring the performance, then learning, and then the same process which I explained to you is happening for the whole years. It was pretty hard. There were so many years, so many days, hot days, like just standing for 8 hours, maybe standing beside the robot in a farm, and that is basically happening for a farmer. I'm not complaining, but this is basically something which I would say you need to be beside your solution, beside your um, uh, device which you're building, or take all the responsibilities to actually see what is the problem, how maybe the farmer in our case is feeling when he's working in the farm the whole day. Something which could keep us alive was basically having a bit of fun. Um, Not much, maybe just a few seconds, but it was basically a teamwork from PhenoRob office to the group in the University of Bonn, and the support which they were giving us. And it was basically relaxing so many of the pressures which we had and we faced beside what we were doing. And we tried to actually get it to a reasonable result. Let's take a deeper look in how the solution works. Basically, solution is like this: the robot goes to the farm, it detects different crops and weeds, and in the front of it, and then there is a weeding tool which it could interact with the plants in the back as the robot moves towards on top of them. So in between, there are so many things happening, like the collection of data, planning, basically extracting information which are important for interaction, and then storing those, and all of these are happening in real time. And then when we take the robot to the farm, this happens. Basically, this is something which is the robot was doing in 2 years ago, only with spray nozzles, so it can detect each of the plants and then act on top of them. So you can see in the sugar beet field in the right side that it doesn't spray on the crops, it only sprays on the weeds. And then because it knows which kind of weed is it, it can adjust the amount of chemicals in that time, because we only had the chemical implementation. So this project basically wrapped up my PhD, and then we tried to, from end of 2023, we tried to get it to the next level and start the startup. So we said, okay, what's gonna bring more value to the farmer's hand will be not dealing with that fancy robot. So we just took all the technology to this trailer, which gets connected to a tractor, basically it doesn't matter how large or how small is the tractor. Basically the weight of the trailer is pretty low, so it can connect to that, and then the farmer just drives the system through the farm, and it doesn't care about anything else. What the system could do, basically, it could manage crops and wheat at the same time. There's a scenario that when it goes to a organic farm, basically we cannot use any chemicals for dealing with weeds, okay? So then it will use mechanical and electrical nozzles for dealing with weeds, and then it could apply microdoses of pesticide or fertilizer on the crops. Then a seamless monitoring is added that it gives the farmers an overview of what is happening in the farm. They could do some processes afterwards, like the post-processing afterwards, and detect or yeah, do some inferencing on the collected data to get some parameters extracted. And then the whole strategy for intervention is plannable. So because there are these unique reading tools which they could move individually, and they have this multi-head nozzle of the reading mechanically, chemically, or electrically, they could basically obtain a plannable or a flexible strategy for intervening with different plants. And then there are different features of the system, which I don't want to go to in. So this is actually the monitoring app which we have developed in the startup. It's a really nice looking software, which it gives the real-time access to the farm, to the machine, and the trials get defined, and then farmer could basically see what is going on in the farm, and if he has several machines or several trials, then basically those will be the information and necessary information of those machines will be in hand in their mobile app or in the browser. And yeah, so we are in a stage that we have collected more than 10 LOIs from farmers with basically without any advertisements, because we were a bit I would say lucky enough to see that no one gave us any negative feedbacks. Sometimes gets negative, sometimes gets scary, I would say, that we don't get any negative feedbacks. But anyway, so we have got more than 3,000 hectares of organic and non-organic farms as a promise for operating or getting our system adapted. We currently got a prize from Bayer. We got to be the first team in their new batch from Bayer Crop Science branch, which is sitting in the Mannheim, and they will basically help us to validate and push the system to the market earlier. And basically, we are having a contract with them for developing some proof of concept projects too. And basically, the startup will move to Mannheim to buy a camp by end of these 2 months. Here I want to just thank you, my crazy team, and the team which basically are pushing the startup. Besides the really um, really warm thanks to the PhenoRob office and the University of Bonn, because it was not it wouldn't be possible definitely without their help. And yeah, I have um, some books which I have added the pictures here if you wanted to basically get a bit more familiar with the startup strategies and all the topics which I talked and much more. These are the four, I would say, the beginner books which everyone in the entrepreneurship should be reading. And yeah, I'm happy to answer your questions if you have any.